Hi friends, very good morning. Welcome to Anu Academy. Very good morning friends. Let us start today's class. Today's class we are going to discuss center of gravity and moment of inertia. At the same time, after completing the material, today's class will discuss some important bits regarding moment of inertia. Okay, so let us start today's class. I think all of you are very serious in your exam preparation, uh, assistant engineering exam conducted by Andhra Pradesh Public Service Commission. Okay, so right now material is ready, material is in front of you. We will start today's class. As I told you, today's class we are starting with center of gravity and moment of inertia. Okay, now let us start today's class. Center of gravity. So center of gravity, we will start with a small definition. We'll come to know the importance of the diagram, and we'll come to know what are the important things, important content we can get from this center of gravity examination point of view. Okay, a point at which whole weight of the body is supposed to be concentrated is called center of gravity. Okay, center of gravity means a point at which whole weight of the body is supposed to be concentrated is called center of gravity. Now we'll see one diagram. With the help of this diagram, we can understand the definition of center of gravity. Okay, so this is the entire diagram, right? So from this diagram, we are learning the importance of center of gravity. So this diagram is showing us this is the x and this is the y. So in this diagram, so this major part of the diagram is the first part of the diagram. So from here to here, this is the first part of the diagram, right? Plus this is the second part of the diagram, this right dotted line, and this triangle is the second part of the diagram. So if we add first part and second part, we are getting this entire diagram. And internal, this is a semicircle shape. This is the internal part of the diagram. Okay, if we remove this one, we are getting we can understand the exact concept of this center of gravity. Okay, so it is always suggested and it is always recommended these special topics. Once we can understand with the help of this diagram, it will be we can remember it for long time. Okay, now we will proceed into our class work. Centroid, see here, centroid may or may not lie on the given figure. If axis of symmetry is inclined at 45 degrees to the horizontal, then x is equal to y. Centroid of quarter circular area is x is equal to y is equal to 4r by 3 pi. Centroid of sector of a circle is given by the relation 2r sin alpha by 3 alpha. Center of gravity for bent wire of shape arc of a circle is given by the relation r sin alpha by alpha. Okay, so that is about the center of gravity. And now we'll discuss moment of inertia. Okay, moment of inertia, right? So here also one diagram is available in order to understand the concept of this moment of inertia. This diagram, okay, so here this is the one part of this diagram. It looks like a triangle, and this square, see from this is the square of this diagram, and this is the semicircle of the diagram. So if we add these three things, we are getting this picture. And internal part of the diagram, this circle is the internal part. So once we remove this, this is the concept of this moment of inertia. Okay, now we will see the remaining things which we can understand under moment of inertia. Perpendicular axis theorem is also called the polar moment of inertia. Okay, moment of inertia of semicircular area about diametrical line is given by a relation pi r to the power 4 by 8. If unit of area is centimeter square and the distance of centroid of area is centimeter, then the unit of moment of inertia will be centimeter to the power 4. If a figure does not have any axis of symmetry, then one has to find centroid before finding moment of inertia about centroidal axis. Okay, area moment of inertia is also called mathematically called the second moment of area. Okay, it is called the second moment of area. Now we will see these bits, important bits, okay, under moment of inertia. Concept of moment of inertia is based on distribution of, first option is only mass, only area, both mass and area, none of these. Okay, see here some questions, fourth option mostly we can find all of the above or none of the, is this type of questions we can see nowadays in our examination, right? So we should not be in hurry burry going for these type of options. We have to think carefully, we have to read the question properly, we have to analyze the options, then only we can go for the correct answer. Now in this case, first one, concept of moment of inertia is based on distribution of only mass, only area. So it is based on the distribution of mass and based on the distribution of area. So the answer is C, both mass and area. Okay, like that we have to think and we have to go for the correct option. Next, perpendicular axis theorem is used while deriving the moment of inertia of rectangle, triangle, circle, square. So four options are given. So the correct option for perpendicular axis theorem is used while deriving the moment of inertia of a circle. So circle is the answer. The relation, next, the relation used by parallel axis theorem. Okay, the relation used by parallel axis theorem is I is equal to Ig plus AR square, I is equal to Ixx plus Iyy, Izz is equal to Ixx plus Iyy, Ig plus AR. Okay, so here the correct option is the relation used by parallel axis theorem is first one, I is equal to Ig plus AR square. Okay, next, the relation used for radius of gyration is I is equal to AK, I is equal to A square into K, I is equal to A square into K square, and I is equal to AK square. Okay, so the relation used by radius of gyration is I is equal to AK square. Okay, next, moment of inertia of triangular area about its base is given by a relation, that is I is equal to BH by 12, I is equal to BH square by 12, I is equal to BH cube by 12, I is equal to BH cube by 36. Okay, so here for the moment of inertia of triangular area about its base is given by a relation is I is equal to BH cube by 12. Okay, next, if the axis of symmetry for given shaded area is inclined at 45 degrees to horizontal, then Ixx equal to 0, Iyy is equal to 0, Izz is equal to 0, Ixx equal to Iyy. So here the correct option is if the axis of symmetry for given shaded area is inclined at 45 degrees to horizontal, then Ixx is equal to Iyy. So this is the option. Next, if figure is symmetric about x axis and y axis, then for finding moment of inertia about centroidal axis we require to find x, y, x and y, none of the is. So here if figure is symmetric but about x axis, x axis and y axis, then for finding moment of inertia about centroidal axis we require to find x, y, x and y. So it is none of these. Okay, it is none of these. This is the option. Okay, now this is the option. So if figure is symmetric about x axis and y axis, then for finding moment of inertia about centroidal axis we require to find is it is not this is not, this is not, this is not, and this is the correct, none of these. Okay, so that's all friends for today's class. I think today's class will be very helpful for you. All of you understood today's class. It will be very helpful for your AE Assistant Engineering Exam preparation conducted by APPSC. So countdown has started. So don't waste your time. Start. Be give lot of time for your preparation. Okay. So think that it is a golden opportunity for getting the government job. Okay. So if you have not subscribed our channel, please subscribe our channel. Please like and share our channel. Please discuss with your friends the class for going on in our channel. Okay. Thank you very much. Thank you for watching.